Hello students, this is Dr. Faizan Mirza. I am discussing genetic drift with you. We know that genetic drift ends up reducing the gene pool that gets limited, and it is not the population which is made, which is produced, is not genetically representative of the original population. There's a loss of genetic variation. We know that that happens in the genetic drift. But genetic drift is actually an outcome of founder's effect as well as of evolutionary bottleneck. So we need to distinguish between what's founder's effect and what's evolutionary bottleneck. So what's founder's effect? Founder's effect occurs when there's a small number of individuals, and these small number of individuals get separated from the larger population and they get isolated. The individuals which get isolated, they have no other option but to breed together. And the larger population and its allele frequencies, they stay unaffected because the larger population can still breed together, whereas the isolated population ends up breeding with one another. So individuals living in that isolated population are just few in number, and the new population in that isolated population is actually coming up from just a few parents, and they actually end up producing offspring which are very similar to one another. The loss of gene pool, or you can say the loss of allele frequency, or the changes in the allele frequency because of the isolation involved here, and since the larger population is unaffected, only the isolated population is being affected. Eventually genetic drift occurs in the isolated population, and the larger population which is unaffected stays normal, and we see that this is founder's effect leading to genetic drift. Evolutionary bottleneck, on the other hand, is not isolation. There is no isolation involved in evolutionary bottleneck. There is no larger population, there is no smaller population being isolated here. In evolutionary bottleneck, population size greatly reduced because of some natural event. A large number of individuals of a population, they would die in an event, for example, a natural disaster, for example, ice age, for example, forest fire, or any natural disaster. And because of those, there is a random selection of genes and survivors reproduce. And when the survivors reproduce, genetic drift occurs because only survivors have the alleles which will be giving rise to the next generation. There was a sudden reduction in the gene pool and a large scale or massive deaths of individuals, of an organism, of a species here at a certain point in time. And that ends up putting a lot of burden on the survivors, because only the survivors will by chance have alleles, and these alleles might not be as suited as the ones which were lost in that natural event. And eventually genetic drift occur. We know genetic drift actually refers to reduction in the gene pool. And what is genetic drift? You can recall, genetic drift is basically change in the allele frequency that occurs by chance because only some organism of each generation reproduce. In bottleneck, it's just those who survive, they reproduce. In founder's effect, it's those who got isolated, they reproduce separately, and the larger population stays unaffected. We can see that evolutionary bottleneck occurred in cheetahs only. And cheetahs, when at the end of ice age, there were many cheetahs. Majority of cheetahs, they died. So when they died, that was just because of the nature striking at that time. And the cheetahs who survived, they were in tribes, and only those cheetahs survived which were living in certain conditions in which they were able to survive from the extremely low temperature of that ice age. Now, when during that ice age, or as it was ending, the mates available for those cheetahs were the close relatives which were living together, and they had no other option but to breed together. And the offsprings that came out were actually from the similar parents. And when the offsprings were growing, and when they would grow to become adults, they would again breed with their siblings or with their close relatives, and again that would give rise to population which is very similar to one another. So this actually leads to genetic drift. So evolutionary bottleneck resulted in the cheetahs being very similar to one another. So today, all the cheetahs that we have globally, they are extremely similar to one another because of an evolutionary bottleneck that occurred sometime like 10,000 years ago. That's it from my side. Thank you so much.